You know, when you're just sitting there in the terminal, looking out that giant glass window at a massive commercial jet, there's this automatic assumption of, like, perfect, almost flawless competence.
Oh, yeah, totally.
I mean, you watch the ground crew swarming around the landing gear, fueling the wings, checking the sensors, and you just assume there is this invisible army of geniuses in the background who know every single inch of that machinery.
Because it is entirely built on trust. I mean, you look at those massive turbine engines and the thousands of moving parts, and you just trust that the system and the people maintaining it are infallible.
Yeah.
Have to, or you'd never get on the plane.
Exactly. And it feels permanent, right? It feels secure. But we are pulling from some really intriguing sources for today's deep dive.
Yeah.
A July 15th, 2026 press release and some extensive white paper excerpts from EON AI Ventures. And they completely shatter that illusion.
You really do.
Yeah. We are exploring this fascinating hidden bottleneck in the global aerospace boom.
Yeah.
And, well, we're looking at how a brand new AI platform called the Aerospace Intelligence Center, or the AIC, aims to completely revolutionize how nations build and keep technical talent. They're teasing this concept of taking nations from the wrench to the orbit.
Which is an incredibly bold claim, to be honest.
Seriously.
They are essentially outlining a roadmap for how a country can literally manufacture an aerospace workforce on demand, bypassing decades of traditional institutional development.
Right, which is exactly why you, listening right now, should care about this, even if you aren't an aerospace engineer. The way we learn, train, and capture human expertise is on the verge of a massive structural shift.
Absolutely.
If a system can manufacture competence for a commercial jet engine or a satellite, it can do it for any industry. But before we get to the solution, we really have to establish the sheer scale of the problem happening right above our heads. Let's look at the numbers.
Yeah, the scale is almost difficult to wrap your head around. To put it in perspective, global aviation hit a record 5.2 billion passengers in 2025.
Wow. 5.2 billion.
Right. That is a massive volume of machinery constantly in motion. You are dealing with extreme temperature fluctuations, high altitude pressure cycles, tremendous mechanical stress.
A lot of wear and tear.
Exactly. Every single one of those flights requires rigorous, highly regulated maintenance by a certified human being.
The wear and tear is relentless. And the white paper highlights this terrifying math problem created by all that demand. The industry desperately needs over 600,000 new aircraft maintenance technicians in the coming decades.
Yeah, and that shortfall is heavily concentrated in the Asia-Pacific region where, the middle class is exploding and air travel is just booming.
And the pipeline to generate those 600,000 technicians is fundamentally broken. Right now, certification takes 5 to 6 years.
Because you cannot just speed run safety-critical training when millions of lives are on the line.
Right, of course.
Meanwhile, the older, highly experienced workers, the ones who hold all the tacit, undocumented knowledge about how these machines actually behave, they're retiring significantly faster than these new trainees can replace them.
Okay, let's unpack this. Because the white paper gives a perfect example of how this plays out in the real world, and that is India. India is the world's third largest aviation market right now. Their commercial fleet is set to triple by 2030.
Triple? That's just wild.
Yeah, triple. But currently, they outsource 80 to 90% of their complex maintenance overseas. They have the planes, but they just don't have the people to fix them.
What's fascinating here is how a commercial logistical issue seamlessly morphs into a massive national security vulnerability.
Oh, totally.
I mean, when a country does not own the mechanics of its own infrastructure, it is not truly independent. A parliamentary panel in India explicitly called this dependency on foreign maintenance a severe economic and national security vulnerability.
It makes sense.
Right. If a geopolitical crisis disrupts supply chains or forces foreign contractors to pull out, a nation's entire aviation network could be grounded almost overnight.
It's like a family buying a fleet of ultra-expensive, high-performance sports cars. They park them all in the driveway, they look incredible, but then they realize literally no one in their zip code knows how to change the oil, recalibrate the sensors, or fix the brakes.
Yes, exactly that.
Every time a warning light comes on, they have to put the car on a boat and ship it to another country. It's totally unsustainable. But let me push back a little on the root cause here. Is this really just a numbers game?
What do you mean?
Like we just need to build more vocational schools? Or is the actual complexity of modern planes making this 5 to 6 year certification simply impossible to speed up with, traditional textbooks and lectures?
Oh, it is absolutely the complexity. Modern aircraft are essentially flying data centers.
Flying data centers, wow.
Yeah, they are infinitely more complex than they were even 20 years ago. You are dealing with advanced composite materials, intricate software ecosystems, highly sensitive avionics. That demands a long, intense training period.
Right.
So you have a slow intake valve for new talent and this massive exhaust valve losing your best, most experienced talent to retirement.
Which brings us to the current Band-Aid solution and why it is fundamentally failing. There's a really revealing quote in the release from Dan Ledgerskar, the founder and chairman of EON AI Ventures.
I love this quote.
Yeah, he says, every nation building its aviation and space future is hitting the same wall it can buy the aircraft, but it can't yet make and keep the people. So developing markets try to bypass the wall by resorting to what EON calls renting competence.
Right. They bring in a major foreign contractor to handle the complex maintenance, repair, and overhaul, what the industry calls MRO.
Gotcha.
The host nation pays a massive premium, and the foreign company flies in their own experts, sets up shop, and fixes the planes.
It is a quick fix. I mean, the planes get back in the air today. But the core problem remains completely untouched.
This raises an important question, though. What happens to a nation's independence and its long-term economic growth when its technical brain power is entirely leased?
Right, because it only works for the duration of the contract.
Exactly. A handful of local engineers might pick up a few peripheral skills, but when that contract ends, the core expertise literally packs its bags and walks out the door. The host nation is left exactly where they started, just with older airplanes that need even more maintenance.
It's exactly like renting a house versus building equity. If you rent an apartment for 10 years, you've spent a fortune, but the day your lease is up, you own nothing.
Nothing to show for
You
it.
have no asset for that capital. EON's alternative with the Aerospace Intelligence Center is to shift a nation from renting foreign expertise to building its own brain power equity. Instead of paying a foreign company to just fix the plane, you deploy a technological infrastructure that manufactures local competence continuously. You are building a sovereign knowledge library that the nation actually owns and controls.
Which is huge.
Yeah. Every single maintenance job, every successful repair makes that national brain power equity smarter and more valuable. The white paper refers to this as capturing work intelligence as a compounding digital asset.
That concept, work intelligence as a compounding digital asset, is the philosophical engine of the AIC. Knowledge is most valuable when it is preserved, scalable, and compounding.
Definitely.
Think about what happens in a normal workplace. When your most senior colleague retires, all their subtle problem-solving skills, their muscle memory, their intuition about how a specific machine vibrates before it fails, all of that vanishes.
It just walks right out the door with them.
Right. EON is proposing a system of record that captures how work is actually done on the hangar floor, digitizes it, and turns it into an asset the nation owns forever.
Philosophically, that makes total sense. Renting brain power leaves you vulnerable. Owning compounding brain power equity makes you powerful. But we need to move from the philosophy to the literal mechanics.
Okay, let's do it.
How does a computer system actually teach someone to fix a satellite or a commercial jet? Because honestly, it sounds incredibly abstract. We really need to talk about the technology.
Let's look at the baseline technology first to understand the leap EON is making here. Conventional immersive trainers, like your standard enterprise VR training modules, they operate on a principle of enumeration.
Enumeration. Okay, let's make sure we define that clearly for everyone.
So enumeration means listing things out one by one. In software training, it means the developers model one specific aircraft type, and they force the user to replay a fixed, rigid script.
Like a checklist you can't deviate from.
Exactly. The software says, do step A, then step B, then step C. It is highly structured, but completely brittle. If you deviate from the script, or if the real-world problem doesn't exactly match the pre-programmed scenario, the training module is effectively useless. It cannot adapt.
Here's where it gets really interesting. EON's new tech, the AIC, completely abandons enumeration and uses something called composition.
Yes, this is the technological breakthrough that makes manufacturing a workforce actually possible.
To visualize this, think about enumeration, like memorizing a pre-glued model airplane. It only goes together one single way. If a piece breaks or you try to attach a different wing, you're totally stuck.
Yeah, you're out of luck.
But composition is entirely different. It's less like a pre-glued model and more like a modern video game physics engine. In a highly advanced video game, the developers don't write a script for every single time a wooden barrel rolls down a hill.
Right, that would take forever.
Exactly. Instead, they program the core rules of gravity, friction, and mass. Because the engine understands the rules, it can accurately simulate the barrel rolling down any hill, bouncing off any object in real time. EIN is applying that kind of systemic understanding to aerospace machinery. The AIC uses a finite library of understood aerospace components, and each one of these components carries what the white paper calls a six-layer competence record.
If we connect this to the bigger picture, the six-layer competence record is the difference between an AI that simply shows you a picture of a part and an AI that fundamentally understands the part. The system ingests massive amounts of engineering data to build these layers.
Okay, let me make sure I'm picturing these layers correctly. We're talking about the AI knowing not just the 3D visual geometry of a fuel valve, but understanding its actual physical properties, right?
Precise.
Like its weight, its thermal limits, the specific safety protocols for handling it, its historical failure modes, and, I don't know, the exact torque required to tighten its bolts.
Yes, all of that. Because the AI has that deep, multi-layered profile for its foundational components, it understands the physics, the safety constraints, and the complex dependencies of how parts interact with each other.
Wow.
It doesn't need a pre-written script. It can take that finite library of understood components and compose any system on any aircraft. And remarkably, using the exact same underlying method, it can compose any system on any satellite.
That is wild. It is one single engine powering everything. From a little two-seater general aviation plane to heavy commercial MRO, all the way to satellite assembly, integration, and testing, what the industry calls AIT.
It's a huge leap.
While competitors are stuck hand-coding one-off training modules for a single specific jet, EON is basically simulating the foundational rules of aerospace itself. Because it understands those rules, the system actively reasons about faults. It runs conditional safety gates dynamically.
It adapts to the messy reality of the problem directly in front of the technician, rather than forcing the technician to conform to a rigid, pre-recorded simulation.
But let me pause you there, because the mechanics of that sound almost impossible based on something else the source material mentions.
Oh, what's that?
It says the system uses a finite library of components, which tracks with what we just discussed, but then it introduces this field layer. It says a worker can use a phone or tablet on the actual hangar floor, pointed at the machinery, and the AI can recognize real undocumented equipment, build its own model on the fly, and then safely guide the worker through a procedure.
Yeah.
How can the system safely guide a mechanic on a machine it has theoretically never seen before? I mean, that sounds like science fiction.
It sounds like magic until you understand how composition actually scales. The AI isn't trying to match a visual picture to a database of predefined, complete machines. It's recognizing the atomic parts.
Atomic parts, okay.
When it scans an undocumented piece of equipment on the hangar floor, it breaks that equipment down into those fundamental understood components. It processes the visual data and says, okay, I haven't seen this exact configuration of a generator before, but I recognize the specific type of hydraulic manifold. I recognize this pressure sensor. I recognize the structural alloy of this housing.
Oh, I see. It's identifying the ecosystem of parts it already knows how to handle.
Exactly. And because it has that six-layer competence record for the individual parts, it can extrapolate how they must safely interact in this new, novel arrangement. It synthesizes a safe procedure by applying known physical, operational, and engineering rules to an unknown configuration.
That is brilliant. So it can build a functional, safe working model of this unknown machine right there on the clean room bench and walk the mechanic through the diagnostic steps.
Yeah, it transforms the mechanic from someone just trying to remember a manual into a problem solver who is actively partnered with an intelligence that truly understands the machine's physics.
So the technology is incredibly advanced. But, you know, the listener is probably wondering what I'm wondering. Does this actually work in practice? We're talking about the mud, the oil, the high-pressure environment of a real hangar where delays cost millions of dollars. Does this technology actually move the needle on that 600,000 technician shortfall?
The metrics gathered from independent studies are actually quite definitive. We're looking at training time reductions on the order of 50%.
Wait, 50%? That is massive, cutting the time in half.
You are literally halving the time it takes to build competence. But crucially, they're also seeing roughly 30% better first-time fix rates and about 40% faster inspections.
That's impressive.
This data is vital because it proves a critical point. You aren't just rushing people through a faster pipeline and lowering safety standards. You are actually producing a significantly higher quality of work.
That fundamentally solves the 5 to 6 year certification bottleneck. If you can cut training time by 50%, but those newer mechanics are actually diagnosing and fixing issues correctly the first time, 30% more often, you've just exponentially increased the capacity and capability of your workforce.
Absolutely.
And the sources note that civil aviation regulators are actually starting to formally recognize these rigorous immersive modules. But I have to ask a direct question about the hardware here, because when I hear immersive training, I immediately picture someone stumbling around a room blindfolded by a bulky, isolating VR headset.
Right, the classic VR look.
Yeah, and I've tried VR. It is a very solo experience. How does this actually work at a national scale? Does an immersive room with no headsets actually work to train an entire cohort of mechanics simultaneously?
The headset-free environment is a critical design choice, especially in a field like aerospace where communication and teamwork are just non-negotiable. The AIC does not isolate users. Instead, they use shared immersive rooms utilizing advanced spatial computing and high-definition projection mapping.
Okay, so projection mapping.
Imagine walking into a large physical room with your entire cohort of trainees. There are no bulky headsets. Instead, a life-sized, highly detailed, interactive 3D model of a commercial turbine engine is projected seamlessly into the space right in front of you.
So the entire team is looking at the same engine in the same physical space. They can make eye contact, point at specific valves, and collaborate naturally.
Exactly. It becomes a collaborative team mission under the guidance of one instructor. It perfectly mirrors the dynamic of how they will actually work together on the tarmac.
That makes so much more sense.
And there's a fascinating strategic application to this hardware as well. The white paper notes that these shared immersive rooms are used to pitch ministry boards or airline executives in a single sitting.
Oh, really?
Yeah, you don't have to awkwardly pass around headsets and explain controls. You simply walk the political and corporate decision makers into the room, project the engine, and let them watch the AI reason through a complex fault in real time.
That is an incredible sales advantage. You put the politicians physically inside the engine and show them the brain power equity they could own. So how does a nation actually deploy this? You obviously don't just order this software online.
No, this is structured as a massive national infrastructure project. The deployment model is a phased public-private rollout. It typically starts with a flagship hub, a massive state-of-the-art immersive facility anchored at the country's main aviation center.
So it's like the nerve center for the nation's technical training.
Exactly. But you can't force everyone to travel to the capital, so they have a portable tier. This is how they achieve true scale. They push this technology out via portable immersive setups to regional operators, local university engineering programs, and military Air Force bases.
So it reaches everywhere.
Yeah, and it is designed to align with, rather than compete against, existing national training systems or civil aviation authorities. It acts as a technological accelerant for the institutions a country already has.
And it is worth noting that this isn't some brand new startup making wild claims. EON AI Ventures has a serious pedigree in this specific space. They're built on the leadership behind EON Reality, which means they have 25 years of experience in spatial computing and immersive learning.
That's a long time in tech.
Yeah, they already have over 4,400 institutional customers across more than 80 countries. They are building this AIC platform on their broader corporate vision called Human 2.0 and what they call the intelligence flywheel.
Those two concepts really tie the whole system together. Human 2.0 isn't about replacing workers with robots. It is about elevating a baseline human worker to an expert level by seamlessly partnering them with spatial AI. And the intelligence flywheel is the mechanism that powers the compounding equity we discussed earlier.
The compounding effect. Okay, let me make sure I understand the flywheel. A mechanic uses the AIC to guide them through a complex repair on the hangar floor. The system records the nuances of that successful fix. That data feeds back into the AI, making the AI smarter. The next mechanic who trains on that system receives better, more nuanced training based on real-world data. They then perform even better on the floor, feeding even better data back into the system. The wheel spins faster and faster, and the nation's brain power equity grows with every single turn.
That is exactly how it works. They are fundamentally turning the fleeting, tacit knowledge of human workers into an owned, permanent digital asset.
So what does this all mean? We've covered a tremendous amount of ground today. We started with the sheer pressure of 600,000 missing mechanics and the reality of developing nations being forced to outsource their sovereignty.
It's a huge issue.
We looked at the critical difference between renting foreign competence and building sovereign brainpower equity. We dove into the mechanics of why dumb enumeration fails and how smart composition, an AI that truly understands the physics, safety, and dependencies of atomic parts, can simulate and guide repairs on unseen equipment. I want to challenge you, the listener, to think about your own workplace right now.
Yeah, it applies everywhere.
It doesn't have to be an aerospace hangar. What would happen if your company or your industry could capture the work intelligence of its absolute best employees before they retire? What if you could turn their daily intuitive actions, their specific problem-solving skills, into a compounding digital asset that your organization simply keeps forever?
It represents a profound shift in how we value labor, training, and knowledge transfer. And, if we take that thought and project it onto the global geopolitical stage, we arrive at a really provocative potential future.
Ooh, tell me.
For decades, the traditional balance of power has favored highly developed nations because they possessed the legacy educational infrastructure, the centuries-old universities and massive technical institutes required to produce world-class experts.
Right.
Developing nations were largely relegated to exporting raw materials or cheap, unskilled labor while being forced to outsource their complex maintenance, as we saw with the India example.
They were structurally trapped in the cycle of renting competence.
But if platforms like the Aerospace Intelligence Center actually deliver on their promise, if they allow developing nations to instantly spin up world-class, sovereign technical workforces without having to wait 50 years to build legacy universities, that traditional geopolitical advantage might completely evaporate.
Wow, that changes the entire global dynamic.
We could be looking at a future where countries that historically exported raw materials and outsourced their technical needs suddenly become the world's leading exporters of cutting-edge technical know-how. What does the global balance of power actually look like when human competence can be downloaded, localized, and scaled overnight?
That is a staggering thought to leave on. The entire map of global economic power could flip, all because we finally figured out how to digitize and scale the mechanic's brain. Thank you so much for joining us on this deep dive. We hope you take that question with you this week and keep questioning the systems that make the world around you run. After all, the journey from the wrench to the orbit might just be a software update away. Catch you next time.